morning, boys and girls. This is week 5 in our online learning, okay? And we started a new chapter last week, and that was about the elements, periodic table, okay? And we're going to move on with this chapter. This week we're going to focus on the periodic table, and we're going to also even start some reactions between elements. So just a little bit of a background on the periodic table. Periodic table is basically a list of all elements. And I'm just going to tell you something that I find fascinating. Now, you look at the world around us. The world around us is made out of matter. There's all kind of matters. There's pens, there's boards, there's paper, there's straw hats, there's fabric hats, there's hair, there's skin, there's teeth, there's billions of things around the world, and they're all very different. They all have different colors, different shapes, different boiling temperature, melting temperature, lots of different things. But it turns out that all these billions and billions of materials are only made out of about 100 or so basic building blocks, which we call elements. Okay? There are only 100 or so elements. So imagine that from these 100 or so, just over 100 building blocks, these like Lego bricks, they are all different to each other. With these building Lego bricks, with these elements, you can make up anything in our world. Okay? From glass to hydrogen gas to and it's not just in our world. It's all this universe around us. And that is fascinating. And so scientists, when they look at the light that come from distant stars, billions and billions light ways, other side of the universe, they look at their light. There is a way, I'm not going to get into how they do it, but by looking at the colors of the light, okay, they can tell what material, what elements are on the other side, on these stars, far away, on the other side of the universe. Just like you have, like fire has a certain orangey yellow color, but the cooking gas we use in the kitchen is more blue. And sometimes if you chuck in some to the fire, there's this green flame. The colors of this burn, of this fire, can tell you what's inside it. It's the same thing that scientists would do with stars. And what they found are that all these 100 or so elements that appear in our world are the same elements that exist on stars on the other side of the universe. I don't know about you, I find that fascinating. So this Russian dude, Mendeleev, about, 150, 160 years ago, came up with a way of arranging all these elements, all these different building blocks of nature in a way, in a certain order. And I'm not going to get into it now, but if you've got some time, you find that interesting, please Google periodic table, and then you can write Mendeleev. I'll write it down for you here. Mendeleev. And he's the one who actually, the first one who put that in a certain order, because you can put it in different order, okay? All the elements. And he was a genius. Okay? Like I said, I'm not going to get into what he did, or how he did it, but just one little thing. In his time, we only knew maybe 10% of these elements. Okay? But his greatness was that he arranged them in a certain order that he knew that, look, I've got one element here, I've got one element there, and I know there's another element in between them. Below the first one, above the second one. I know that there's an element, and he could even tell its properties, how much does it weigh, and all that sort of stuff, but we just haven't found it yet. How genius can that be? Okay? And it's all because of the way he arranged it. Okay? Now, this year we're just going to introduce you to the way this periodic table is arranged. Well, just a few basic things about it. It will take you years to really understand the order, the structure, the pattern behind this periodic table. Okay? By high school, you might have some kind of understanding. Okay? So it's a long process. Okay, so let's have a look at the periodic table. Now, by the way, underneath this lesson, I've attached a file with a periodic table, okay? And what I would like you to do is, if you've got a printer, fantastic, just print that file, okay? If not, just copy that file and put it in your class note, not your homework folder, but your class note folder. It's also under your name. And then all the notes that I'm doing now, I want you to do onto your periodic table. So if you've got a printer, pause me now, print that little periodic table, and then draw things on that paper as I'm drawing them here. If you don't have a printer, nothing to worry about. Just when I finish, okay, just listen to me first, all my drawing, and then copy all the stuff that I've done onto your own digital periodic table that you need to put on your class note. If you don't understand that, just WhatsApp. Okay, so we've got the periodic table. I think the first thing I'm going to say here, I'm going to give you quite a lot of information. The first thing I need to say is that we've got a division here. We've got a division between metals and non-metals. And the division is here. We'll just leave that. Okay. Maybe I should also say, in your periodic table, you might have these two separate rows, or you might not. In either case, I'm not going to deal with that. So you really don't have to worry about it. Okay? But the division, I don't know if you can see really this line. I'll just draw it with purple. That's hopefully a little bit stronger. Okay? Anyways, I'm sure you guys see these green, the green color here. Anything to the left of this green elements, including the green elements, are called metals. Just write it down here. Metals. You see when I say right metals? Yes. These are the metals. Okay? I'm just going to pause to get rid of some light. Okay. So hopefully that's a little less light now. So on the left side, from this line that has aluminium, gallium, tin, and bismuth, everything to the left is a metal. And that means that anything to the right is called non-metals. Non-metals. Okay? Now, what's the difference between metals and non-metals? You kind of know already some. Metals like iron, like copper, like zinc, like silver, like gold, okay? They've got some common properties, okay? And I will make note of that. Common properties is that they conduct electricity, okay? They conduct also heat. We're going to learn about both of these things next year. Okay? Conduct heat means that if you put some heat source on them, they will transfer that heat. Okay? Also, almost all of them, in fact, all of them except for one, okay, which see if you can figure out which one, all but one are solid in room temperature. That means they have a high melting point. Okay, think about it: silver, gold, iron, copper. They're always in a solid form. Okay, and also they're hard, they're strong. Okay, what about non-metals? Okay, non-metals like nitrogen, oxygen, fluorine, chlorine, iodine. Now they have, okay, so all of them don't conduct electricity. You can't use them to pass electricity, and they don't conduct heat as well. Okay, now some of them are gases, some of them are liquid, and there are a few solids. So they vary in that respect. They're not all gas or not all liquid, and the solid ones are also brittle. What does brittle mean? Brittle like glass. What does it brittle mean? They break. Okay? If I drop a metal like my keys here, they're not going to break. But if I drop the glass, it will shatter. That means it's brittle. So I'm just going to pause and make these notes, and I'd like you to do what I'm doing. Make that separation. Write these notes onto your periodic table. Okay. So I'm just going to repeat what I've said here and just pause me and then copy that. Okay, so metals are mostly solid in room temperature. Okay, if you did manage to guess, the one exception is mercury. Mercury that is used to be in our thermometers, and still in some of them, is actually liquid in room temperature. They all conduct heat and electricity. And the last thing which I didn't say is that they are shiny. Shiny. Which movie is that from? So shiny, sparkling. Okay. Now, non-metals, they're insulators. They don't conduct heat or electricity. They're brittle often. If they're solid, they will break. And they can be gas, liquid, or solid. Mainly gas, but there's liquid and solids there as well. They vary there. Okay, important that you know where they are in the periodic table. I think the last thing I didn't mention, I'll write it now, is the transition metal. Okay, transition metals are metals. They appear on the one in the red, in the middle. Okay, so you see you've got like a block here, you've got a block there, a block in the middle. That's called a transition metal. And to be honest, you need to know nothing about it apart from it's called transition metal. Okay, that's it. That's all you need to know. For high school, really, even. You're not going to deal with it much later. So I want you guys to just copy that. Okay, I'm going to finish up here. Okay, it's not the end of the lesson. The video is getting a bit longer, so I'll do one more video after this. See you in a bit.